Installing a grounding system is crucial for lightning protection, particularly in environments like baseball parks with extensive lighting infrastructure. The National Electrical Code and industry best practices emphasize the importance of a robust grounding system to safely dissipate lightning strikes into the earth. Ground rods play a pivotal role in this system. These are metal rods, typically made of copper or copper-clad steel, driven into the earth to establish a low-resistance electrical connection to the ground. This low-resistance path is essential for quickly diverting lightning energy away from sensitive equipment and personnel. A grounding conductor, typically a 2 American wire-gauge copper wire, is connected to the ground rod and routed to the electrical equipment requiring protection. This conductor serves as the primary pathway for lightning current to flow to the ground. For baseball park lighting, it's highly recommended to install a ground rod at each pole location where lighting fixtures are installed. This ensures that each lighting pole has its own dedicated grounding point, minimizing the risk of lightning damage. The ground rod should be driven into the earth at a depth of at least 8 feet to ensure it reaches sufficiently conductive soil. It should also be placed at a distance of no less than 6 feet from the pole to prevent any potential step voltage hazards during a lightning strike. Once the ground rod is properly installed, the 2 copper grounding conductor is connected to it using a grounding clamp or other approved method. This connection must be secure and corrosion resistant to maintain its effectiveness over time. The 2 copper grounding conductor from the ground rod should also be connected to the equipment grounding conductor of the lighting fixture. The equipment grounding conductor is typically a green or bare copper wire that provides a low impedance path for electrical current to flow back to the electrical source in case of a short circuit or lightning strike. By connecting the ground rod to the equipment grounding conductor, you create a comprehensive grounding network that provides multiple pathways for lightning energy to dissipate. The primary purpose of lightning protection grounding is to create a low-resistance path to the ground, allowing the lightning protection system to safely dissipate lightning energy. This protects the lighting fixtures, electrical equipment, and, most importantly, people from potential damage or injury. The grounding system helps to minimize the risk of equipment failure, fires, and electrical shock hazards associated with lightning strikes. In the event of a lightning strike, the lightning current will preferentially flow through the low-resistance path provided by the grounding system rather than through the lighting fixtures or other electrical equipment. This helps to prevent damage to these components and reduces the risk of electrical hazards. Grounding systems play a critical role in protecting both equipment and people from the dangers of lightning strikes. The National Electrical Code provides detailed requirements for grounding and bonding electrical systems, including those used for lightning protection. Adhering to these requirements is essential for ensuring the safety and effectiveness of the grounding system. Section 250 of the National Electrical Code covers grounding electrode systems. It requires that all grounding electrodes that are present at each building or structure be bonded together to form a grounding electrode system. This includes metal underground water pipes, metal building frames, concrete encased electrodes, and ground rods. Section 250. 52 outlines the requirements for specific grounding electrodes. It specifies the minimum size and installation requirements for various types of grounding electrodes, including ground rods, pipes, and plates. Section 250. 66 provides guidance on sizing the grounding electrode conductor. The grounding electrode conductor connects the grounding electrode system to the equipment grounding conductor and the neutral conductor at the service equipment. Section 250. 166 covers sizing the equipment grounding conductor for alternating current systems. The size of the equipment grounding conductor is based on the size of the overcurrent protective device protecting the circuit. For example, Table 250. 122 specifies the minimum sizes for equipment grounding conductors based on the rating of the overcurrent device. Proper selection and installation of grounding components are critical for ensuring the effectiveness of the lightning protection system. Ground rod should be made of corrosion-resistant materials such as copper or copper-clad steel. Grounding clamps and connectors should also be made of compatible materials to prevent galvanic corrosion. The connections between the grounding conductor and the ground rod, and between the grounding conductor and the equipment grounding conductor, must be secure and corrosion resistant. Regular inspection and maintenance of the grounding system are essential for ensuring its continued effectiveness. Ground rods and connections should be inspected periodically for signs of corrosion or damage. Any damaged or corroded component should be replaced immediately. Soil conditions can also affect the effectiveness of the grounding system. Dry or sandy soil has a higher resistance than moist or clay soil. In areas with poor soil conditions, it may be necessary to install additional ground rods or use ground-enhancing compounds to improve the effectiveness of the grounding system. Ground-enhancing compounds are materials that are designed to improve the conductivity of the soil around the ground rod. These compounds can help to reduce the resistance of the grounding system, especially in areas with poor soil conditions. When installing a lightning protection system, it's important to consult with a qualified electrical contractor or lightning protection specialist. These professionals can assess the specific risks and requirements of the site and design a grounding system that meets all applicable codes and standards. They can also provide guidance on selecting the appropriate grounding components and ensuring proper installation. In addition to ground rods and grounding conductors, surge protective devices, also known as SPD, are an important part of a comprehensive lightning protection system. SPD are designed to protect sensitive electronic equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD should be installed at the service entrance and at any sub-panels or branch circuits that serve sensitive equipment. They work by diverting excess voltage to ground, preventing it from reaching the protected equipment. There are several different types of SPD available, each with its own characteristics and performance capabilities. It's important to select SPD that are appropriate for the specific application and the expected level of surge activity. Proper grounding and bonding are essential for the effective operation of SPD. The SPD must be properly grounded to provide a low impedance path for the surge current to flow to ground. The grounding conductor should be as short and straight as possible to minimize impedance. Bonding is the process of connecting all metallic components of the electrical system together to create a common ground reference. This helps to equalize voltage potentials and reduce the risk of electrical shock hazards. Bonding should be performed in accordance with the requirements of the National Electrical Code. In addition to the electrical grounding system, it's also important to consider the structural lightning protection system. This system is designed to protect the building structure itself from lightning strikes. It typically consists of air terminals, also known as lightning rods, that are installed on the roof of the building. These air terminals are connected to a network of down conductors that run down the sides of the building and are connected to a grounding system. The purpose of the structural lightning protection system is to intercept lightning strikes and safely conduct the current to ground, preventing damage to the building structure. The design and installation of structural lightning protection systems should be performed by qualified lightning protection specialists in accordance with industry standards such as NFPA 780, standard for the installation of lightning protection systems. Regular inspections and maintenance of the structural lightning protection system are also important for ensuring its continued effectiveness. The air terminals, down conductors, and grounding connections should be inspected periodically for signs of damage or corrosion. Any damaged or corroded component should be repaired or replaced immediately. Trees can also pose a lightning hazard, especially if they are located close to buildings or other structures. Lightning can strike trees and travel through the roots to nearby structures, causing damage or injury. To mitigate this risk, it may be necessary to install lightning protection systems for trees. These systems typically consist of an air terminal installed in the tree, connected to a down conductor that runs down the trunk of the tree and is connected to a grounding system. The grounding system should be located away from the building or other structures to prevent lightning current from flowing into them. When installing lightning protection systems for trees, it's important to consult with a qualified arborist or lightning protection specialist. They can assess the specific risks and requirements of the site and design a system that is appropriate for the size and species of tree. They can also provide guidance on selecting the appropriate components and ensuring proper installation. In addition to the technical aspects of lightning protection, it's also important to educate people about lightning safety. People should be aware of the risks of lightning and know what to do to protect themselves during a thunderstorm. This includes seeking shelter indoors, avoiding contact with metal objects, and staying away from water. Lightning detection systems can also be used to provide early warnings of approaching thunderstorms. These systems use sensors to detect lightning activity in the area and provide alerts to people who may be at risk. Lightning detection systems can be particularly useful in outdoor venues such as baseball parks, where people may be exposed to lightning hazards. Effective lightning protection requires a multifaceted approach that includes proper grounding and bonding, surge protection, structural lightning protection, tree lightning protection, and public education. By implementing these measures, it's possible to significantly reduce the risks of lightning damage and injury. The initial step involves a thorough assessment of the site to identify potential lightning hazards and determine the appropriate level of protection. This assessment should take into account factors such as the geographic location, the type of building or structure, the presence of trees or other potential lightning attractors, and the sensitivity of the equipment being protected. Next, a detailed lightning protection plan should be developed based on the results of the site assessment. This plan should specify the type and location of all lightning protection components, including ground rods, grounding conductors, surge protective devices, air terminals, and down conductors. The lightning protection plan should also include detailed installation instructions and maintenance procedures. All lightning protection components should be selected and installed in accordance with applicable codes and standards such as the National Electrical Code and NFPA 780. It's important to use high-quality components that are designed for lightning protection applications. The installation should be performed by qualified electrical contractors or lightning protection specialists who have experience in installing these systems. After the lightning protection system has been installed, it should be inspected and tested to verify that it is functioning properly. This inspection should include a visual inspection of all components, as well as electrical testing to verify the continuity of the grounding system and the effectiveness of the surge protective devices. Regular maintenance of the lightning protection system is essential for ensuring its continued effectiveness. This maintenance should include periodic inspections of all components, as well as electrical testing to verify that the system is still functioning properly. Any damaged or corroded component should be repaired or replaced immediately. A comprehensive lightning protection program should also include training for employees and occupants of the building or structure. This training should cover the risks of lightning, the operation of the lightning protection system, and the procedures to follow in the event of a thunderstorm. The training should be conducted on a regular basis to ensure that everyone is aware of the risks and knows what to do to protect themselves. Lightning protection is not a one-time investment, but rather an ongoing process that requires regular attention and maintenance. By implementing a comprehensive lightning protection program, it's possible to significantly reduce the risks of lightning damage and injury, protecting people, property, and critical infrastructure. Remember to always consult with qualified professionals for the design, installation, and maintenance of lightning protection systems to ensure safety and compliance with applicable codes and standards. And never underestimate the power of lightning and the importance of taking appropriate precautions to protect yourself and your property.